Hello friends, today we are going to analyze the given overhang beam using the Macaulay's method. Now for the given beam, first we have to calculate the support reaction, and at location D, due to the roller support, we will have vertical reaction as a RD. At hinge support at location A, vertical reaction as a RA and horizontal reaction as a HA, but due to the absence of horizontal as well as inclined loading, our HA value is 0. So our value for HA as a 0. Now taking the first equilibrium condition, which is taking moment at location A as a 0 and taking clockwise moment as a positive, then at location A 35 kN per meter UDL creates clockwise moment, hence it is positive 35, total span length as a 4 meter as a total load, and CG distance is 4/2 from location A. Due to 20 kN, it also creates clockwise moment, so it is positive 20 into total value is 4 plus 2 as a 6 meter. 35 kN point load at location E creates clockwise moment, so it is positive 25 into total span length is 4 plus 2 plus 2 plus 2 as a 10 meter from A, so it is 25 into 10. RD creates anticlockwise moment, so it is minus RD, and perpendicular distance from A is 4 plus 2 plus 2 as a 8, which is equal to 0. Now solving this term, we will have our value for RD, which is equal to 81.25 kilonewton. So our reaction at location D is 81.25 kilonewton. Now if we take the second equilibrium condition as a sigma V equal to 0, then upward reaction is RA and RD, which must be equal to downward loading, and 35 kN per meter into 4 as a UDL downward load, 20 kN point load as a 20 and 25 in downward direction. Now putting the value of RD as a 81.25 in this equation, we will have reaction at A as a 103.75 kilonewton. Now after calculating the support reaction, we have to select a section in the last span of the given beam, and that must cut the UDL on the span. So if we take a section between D to E from location A as a origin, and distance is assumed as a x, but according to the method it does not cut the UDL, so we have to apply a UDL through B2 section in the downward direction as well as B2 section in the upward direction. So we have to plus and minus same amount of UDL up to the section as shown in the figure. Now if we take the moment at this section, we will have moment which is equal to, now at section 103.75 in clockwise direction, so it is positive 103.75 into x. Now 35 kN per meter total downward UDL creates anticlockwise moment, so it is minus 35 into x by 2 as a 35 x square by 2 in anticlockwise moment. Now 20 kN is also creates anticlockwise moment, so it is minus 20 into total value is x, and 20 kN is at 6 meter from the location A, so from section it is total x minus 6 meter. What UDL creates clockwise moment, so it is positive 35 as a UDL value, distance is total x minus 4, and CG distance is x minus 4/2, so it is x minus 4 square by 2. Now 81.25 due to the reaction at D creates clockwise moment at section, so it is positive 81.25 into the distance is total x minus 8 meter. So this is the moment at this section. Now we have to apply elastic curve equation, and it is as EI d square y by dx square as a minus m. So we have to multiply minus with this term and separating this moment we will have now integrating this term we will have ei dy by dx which is equal to now x integration as a x square by 2 plus c1 as a integration constant 35 x cube by 3 into 2 as a 6 20. Now x minus 6 is treated as a one term, so it is x minus 6 all square by 2 minus 35 x minus 4 square integration as a cube by 3 and 2 is there, so 3 into 2 as a 6 and minus 81.25 x minus 8 square by 2. Again integrating this term we will have eiy as a x square by 2 as a x cube by 6 plus c1x plus c2 as a second integration constant 35 x cube by 6 as a x raised to 4 by 24 20 into x minus 6 square by 2 as a cube by 6 minus 35 x minus 4 cube by 6 as a 4 divided by 24 and minus 81.25 x minus 8 square by 2 as a x minus 8 cube divided by 6. Now we have to calculate the integration constant as a c1 and c2 using the boundary condition, and we know that at location A our deflection is 0 and at this location our value of x is 0 as A and origin both are at same place. So let us put the value x equal to 0 in second equation. So our value for y is 0. Now x is 0, so first term is 0, c1 into 0 as a 0, c2 is constant, x raised to 4, so 0. Now here 0 minus 6 which is x minus a is less than 0. So we have to ignore a term x minus a 0 in wall calculation according to the method. So the value for 20 by 6, 0 minus 6 cube as a 0, 0 minus 4 as a minus 4. So this term is 0 and 0 minus 8 as a minus 8. This term is also 0. So our first constant c2 as a 0. Now at roller support also our deflection is 0. But this roller support is at 8 meters from the location A. So we have to put the x equal to 8 meter in this equation. We will have here 20 by 6 is constant, 8 minus 6 as a 2 minus 35 by 24 is constant, 8 minus 4 as a 4 and 8 minus 8 as a 0, so it is ignored. Now solving this term we will have the value for c1 as 403.33. So using boundary condition we will have the integration constant c1 and c2. Let us put this c1 and c2 in equation of slope and deflection and reforming this equation as a final equation for the given beam as so these are the slope and deflection of given span for any location. Now we have to calculate slope at location A. It means at point A, which is exactly at origin, we have to put the value x as a 0. We will have EI theta at location A, which is equal to, now 0 square as a 0, constant value is 403.33. Now x cube as a 0. 0 minus 6, it means minus 6, so we have to ignore it. 0 minus 4 as a minus 4 and 0 minus 8 as a minus 8. So we have to ignore all the term, and the value for theta A, which is 403.33 by EI in terms of kilonewton meter square. Similarly, we have to calculate deflection at location E. So at location E, our x value is 4 plus 2 plus 2 plus 2 as a 10 meter. So let us put the value x equal to 10 meter. In equation D of deflection, we have EI y at location E, which is 10 minus 6 as a 4 cube. Ten minus 4 as a 6 raised to 4. Ten minus 8 as a 2 cube. Now solving this term, we will have from this equation we have EIYE, which is equal to minus 460.04, or we can say that YE is equal to minus 460.04 by EI in terms of kilonewton meter cube, and the negative value indicates that our deflection is in the upward direction at location E. So thus we can calculate the slope and deflection at any location by forming the final slope and deflection equation using the Macaulay's method. Thank you.